Motion Lab report featuring me and all these group members. So these are a table of quantities. They include vertical displacement, horizontal displacement, initial vertical velocity, initial horizontal velocity, time and acceleration, and initial vertical velocity is 0, by the way, so we're not really going to use this. And these two are the independent and dependent variables respectively. So what we know about the lab prior knowledge is that the marble rolls down a frictionless ramp. So um, its gravitational potential energy is fully converted into kinetic energy, and there's no factors to slow the marble down. And which means, or sorry, based on like how the ramp looks, there is no theta value, so the initial vertical velocity is 0, shown over here. Or this is how everything's converted into kinetic energy. This next slide over here shows that vertical velocity is 0, and this slide over here shows the equation derived from these two, from finding the um, vertical and horizontal displacements. So it's this equation right here. So we're able to find out that the relation between these two will be in the form y equals ax to the power of n. And our question is, how does the initial height affect the horizontal displacement in a projectile motion? So the hypothesis is, if dx increases at a constant rate, then dy will increase exponentially by the power of 1 over 2 because of the predicted equation, this, which I've shown you guys, is shown in the thing that I've just showed you, and I expect to see similar results to this graph right here, which is basically ax to the power of n, and just plug in a square root of 1.1. It's right here. So let me just go back. So these are the materials, basically what we need for the setup. So you want to do it near a stairwell and have all these things with you. And you need to follow this procedure, which I won't mention because it takes too long. So these are the quantities that are found from doing the experiment and basically looking at these and plotting them in a regression graph. So over here, it gives you a graph like this, which is very similar to the one that we predicted. And it shows an exponential relationship. So this is kind of like a setup of the experiment. You have the cup of water which you dip the marble into, so that when it lands in the paper, it kind of gives a watermark, and then you can measure the average of the watermark, or the midpoint of it, and then from that you can find the distance from that middle to the stairwell, and that'll give you the displacement, the x displacement. So this is like the percentage of errors that we could have gotten, and we calculated this. And these are some more errors, including not taking friction into account, and incorrectly dropping the marble, and incorrectly measuring the watermark. So in conclusion, I found the A value to be this number and the N value to be this number. N is kind of similar to what I was looking for, but the A value was a lot less than what I was looking for, because I was looking for the square root of 1.1, which is actually this number. So I'm guessing that basically what I said here is that it's a result of not taking friction into account, and further studies can include taking friction into account and other things. So that's my presentation. Alright, so in the last video we used a water bottle to create like a vaping effect, but I think it's time we move on to the next level, right? So this time we're not using a water bottle. We're only going to use the power of our mouth. So I'm sure everyone knows how to make this sound with the top of their mouth and their tongue, right? So basically you hold a lot of air in your mouth and you just keep on making that sound like so. And then once you feel like the air in your, it's hard to explain, but once you feel like the air in your mouth get a little bit hotter, you just blow, like you blow into your mouth as hard as you can. So like this. And then what I just saw was like a little vape cloud. Now you wouldn't really see that through this camera, but if you try it and you get it right, you will like accomplish that effect. So that was my video. Thank you for watching, and I'll see you in a few weeks.